All right, so let's try this one. Well, you can't really see it because I haven't drawn it, but this is going to be problem 6-3. So let's see if I can draw this right. So we've got a beam 6, 6, 6, and 6. So we've got a kind of a roller here and a pin here. So this is A, B, and C is right in the middle, and these all have the dimensions of 6 feet. And the thing that we're going to work on today is the shear to the left of B. The first thing I want to do is find that. So there's B. Let's cut the structure just to the left. And let's decide what piece do we want to work, the left side or the right side?
I worked, when I did I worked on the left side.
I don't think it matters. The right side's pretty small.
Yeah, I'll say right side.
Why not? We'll work the right side. So if I want to work the right side, I need the reaction at B. Everybody see that? So what I'll do first is I'll come over here and I want to find my reaction at B, which will be right about here. So there's BY, there's AY. That has, let's see, that's 6 feet. Then 2 of those makes 12 and 6. And then I'll have my my influence line. I'll assume there's my unit load of 1 at some distance x from the left side. Yeah.
Question. So so the x, what will be the value of the other side?
The distance from here to here?
Yes.
What do you think it is?
Why you only count that distance? Not
Well, we always measure x from left to right. So at this position, it's at a position x.
But why did you stop at B1?
I didn't stop anywhere.
No, I'm talking about the x. 12 minus x.
No. What's the total distance from the left side to B? 18. So this is going to be 18 minus x. So this piece here will be 18 minus x. See that? So now I'm going to sum moments at... Oh, I don't care about that. I'm trying to find BY, aren't I? So I'm going to sum moments at A. Is that correct? Okay, so that I drew that incorrectly. So let's do this. So that means that what's this little distance right in here?
6.
No. It's going to be x minus 6.
And you look for A.
I got confused last time trying to figure out how to do it that way, so
Yeah.
I solved for, I had some moments at B first, got AY, and then got...
Well, you shouldn't make it too hard. It's just simple geometry. Stuff's got to add up, right?
Yeah.
I want this point right here. I know that's a distance x from the left. I know this is 6, so it's got to be the difference, x minus 6.
Yeah.
I was getting ready to sum moments about B, but I want B, so I'm going to sum moments about A. So if I sum moments about A, what do I get? Well, I'll have my unit load 1 creating negative moment with a moment arm of x minus 6. And then BY creates positive moment, and what's its moment arm? 12. So that means that BY is going to be x minus 6 divided by 12. Okay? That's not using the Mueller-Breslau principle. We'll do that one in a second. But let's just say we're doing it this way. So now what do? We come back to this free body. I'll do that over here. So I'll look at the right side. And now I have By. It's right there. And it's x minus 6 over 12. Cantilever. And then what do I have internally? There's the positive shear. Just to the left of B. What else is on that free body? That's it. So how do I find the shear at that point? Some forces in the y direction. Make sure it's in equilibrium. I'll assume up is positive, so I have the shear acting up plus my reaction force, which is x minus 6 over 12. So it says the shear is minus x minus 6 over 12. Now, why is my unit load not there? Because it's operating somewhere between 0 and 18. So this is the case where Mr. Santana is walking around over the first 18 feet of the beam. Anywhere he wants. And because he's walking around over here on the left, if I'm using the right-hand side, he's not there. But if he decides to walk between 18 and 24, then what changes? Well, we kind of have the same free body diagram. Oh, by the way, I forgot, this was 6 feet. It's still going to be 6 feet. So I still have my By reaction, x minus 6 over 12. I still have my shear just to the left of B. But now, Mr. Santana is here. Does it really matter what position he is? No, because I'm finding shear, so all I have to do is sum forces, right? So I'll do the same thing. If we were summing moments here, then we wouldn't know his position too, so we'd have to figure out what this is. But right now I don't care, I'm just finding shear. So I'm going to sum forces in the y direction, assume up is positive. So I got a little sloppy there, that's shear. So we'll have our positive shear acting up. My reaction is also acting up. That's x minus 6 over 12. And now I have my 1 down. So my shear will be equal to minus x minus 6 over 12 plus 1. And you can wiggle this around if you want to and make it a little nicer. This becomes minus x over 12. This becomes positive, what is that? A half. And positive a half plus 1 is 1.5. So you can make a little correction. Or you can just plot it. And that's what we'll do. So if we now come back and construct the influence line, I'll just put some marks there so I'll know where I'm going. And this is going to be the shear, I'll say, left of B, LB, left of B. So this equation is good for the first 18, so I'll plot that. At x equals 0, what do I have? Minus 6 over 12, that's a half. Change signs, it becomes what? Positive 1/2, right? At x equals 6, what do I get? 0. At x equal 18, what do I get? Minus 1. What else? That's it. So now we go to the left of B. I put in minus 18. What do I get? Not minus. I put in 18. What do I get? I get negative 1 plus 1 is 0. If I put in 24, what do I get? I get 18 over 12, which is 1.5. That's negative. Negative 1.5 plus 1 is negative 1/2. There's your shear line.
So weird.
Yes.
So let's say they use that same free body diagram, but try to find the reaction at A. So X would be there, but the other side would be, is it 18 minus X? Still 18 minus X?
Well, if I want to find the reaction for AY, I just say AY plus BY has got to equal to 1.
No.
So I got BY, I can just solve it.
You don't have BY, solve from the square.
Well, then I would sum moments about B,
yeah.
and I would use a moment arm for my 1 of 18 minus X.
So it still be the same.
The same as?
The distance from X, and then the other side will be 18 minus X.
Yeah.
Because you count from...
Because when X gets greater than 18, this becomes then a negative value, and that changes the moment to negative. But right now it's a positive moment. It become a negative moment. So it automatically changed the direction of the moment for you. Did you guys get this? No, half the class did this. Half the class did this, and the other half did this.
I think.
Wait, a half plus a half plus a half. Yeah, that's right.
It's a positive half and another half.
Crazy, isn't it? What's the change in shear here? 1. Magic. Now, how could Mueller-Breslau predict that? This is where you have to think creatively. Can you guys do that? I don't know if I can. So that means I have to put my little shearless connector just to the left, right? So let's imagine what that would look like. So I've got my beam, and I've got a roller here. And I get just there, and there's my magic shear connector. Okay? Just so you can see a little better, let's not get really, 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 really close. Let's just kind of squeeze it off to the side a little bit. Okay? So I'll put positive shear here, and I'll put positive shear there. What's this side do? Has to go down. So that means you get that part. Right? What's this side have to do? Has to go up. So this has to go like that. Get the same shape. And since as this gets closer and closer and closer, this little value gets down to nothing. And then you'll know that this change has to be 1, right? And if you know this is 1 and this is 12, then what would be this value over 6? Similar triangles, right? 1 is to 12 as what is to 6? 1/2. This is also a similar triangle. This slope is the same. So again, 12 is to 1 as 6 is to 1/2. So I could have drawn that right off the top of my head. Well, not really. I'm processing. And plus I get that purple smoke blowing out. Poof! Super cool, huh? Just one?
Yeah, just one.
Okay.
So you were going to ask another reaction, C, right next to BY. Another reaction.
You want to find the AY reaction?
No, I say add another reaction.
We can't add
another supporter.
Can't do that. That'd be an indeterminate problem. Right? That'd be 3 unknowns. Can't do that.
I try to understand how did you get x and then why is it not 24 minus x but 18 minus x?
You mean the distance from B to here? This distance?
Yes, but why isn't you do 24 minus x because the whole distance is 24?
Because that whole distance is not 24, it's 18. The distance from here to B is 18.
So you stop at B.
Well, we're trying to find it at B, right?
Okay.
So our base for our measurement is B. So everything has to be measured from B. And B is 18 inches. If I was curious about out here on the free end, then I'd be working at 24 inches.
Yeah.
It's just like when I stopped here and I'm looking at the left side, right? Right here. Well, I know that distance is x. I know this distance is 6. So what does this distance in between have to be? X minus 6. And that works for any place until there. Actually, if I wanted to keep going, it would still be x minus 6. The distance from here to there is still going to be x minus 6. So look at all that work we had to do when, I know you can't see it on the video, but on the board I drew the whole thing in probably 15 seconds. Okay. I get this.